HVAC temp rise formula to measure airflow. CFM lets you quickly calculate actual cubic feet per minute by using measured temperature rise and system heat input. To calculate airflow accurately, measure the temperature rise across the coil or heat exchanger with a well-calibrated digital thermometer reading to 1 decimal when possible. Record supply and return temperatures at steady-state operation after the system has run for at least 10 minutes to stabilize. Know the specific heat of air at room conditions approximately 0.20 4 BTU per pound degree Fahrenheit, and the air density at your site altitude and temperature. Use measured static pressure to verify the blower is operating on its curve because density shifts change CFM results. Use the formula CFM equals BTU per hour heat input divided by 1,200 times temperature rise when working in British thermal units, and convert electrical and fuel input to sensible heat input by subtracting combustion losses or accounting for compressor heat rejection in heat pump systems. For fan-powered systems, confirm the supply plenum temperature sensor is located at least 2 duct diameters downstream of transitions to avoid skew from turbulence. Average 3 measurements across the duct cross-section for more accurate return and supply deltas if you cannot access a velocity traverse. When using a temporary pitot traverse, calibrate the manometer against a known standard and correct for probe alignment. Compensate for velocity profile by applying the appropriate correction factor based on duct shape and Reynolds number. If the job requires high accuracy, weigh anemometer results against the temperature rise method and an independent flow hood at terminals, and reconcile discrepancies by checking for bypasses, return leaks, or unaccounted bypass dampers. Always log ambient conditions, fuel type, and controller set points so calculations can be audited and repeated. One of the most common mistakes is using incorrect heat input values or ignoring system losses when searching for HVAC temperature rise formula or airflow CFM causes wrong CFM estimates. Fix it by measuring actual burner or electrical input and applying efficiency corrections. One of the next frequent issues is failing to verify power off before setup, leading to electrical hazard and damaged instruments when measuring temps or opening compartments. Fix by switching off the breaker, testing for voltage with a properly rated multimeter at the service disconnect, and confirming no voltage present at the terminal block before touching wiring. One of the third common faults is poor temperature sensor placement that gives non-representative supply or return readings and ruins calculated CFM. Fix by following placement rules. Steady state operation, 2 duct diameters downstream of disturbance, average multiple points or use a flow-corrected traverse, and document sensor type and calibration date. BigHomeProjects.com lists trusted local HVAC contractors and provides a searchable directory tailored to projects like airflow verification and system balancing. It helps homeowners find qualified technicians quickly and helps contractors get local leads for work, such as accurate temperature rise testing and safe power off setup.